Welcome to lesson 1 of unit 7. Unit 7 is going to be all about right triangles. So as you can see in this first slide, we're only going to be talking about right triangles in unit 7. So the first thing I'm going to do is go over some basics about how we're going to approach solving the problems for similar right triangles. First, if you look at the theorem, the example, you'll see that they've already went ahead and separated the triangles out for you. So that's going to be one of the huge keys of this unit. So when you see right triangles and they are all smushed together like that, you're always going to want to separate. So that's key number 1. Okay. Now, it is showing that the smaller triangle is the blue one, the medium triangle is the green one, and then the overall largest triangle we have with vertices A, C, and B. Okay? And for the large triangle, the right angle, because again, we're always dealing with right triangles, is at vertex C. Now, the one rule about similar right triangles is that they are all similar, right? It's right in the name. So if you look over here, it is saying that all the color triangles are similar to each other. So when we say similar, if you remember, it means two things. First, angles are congruent. Okay? And the second thing is the sides are not congruent, but the sides are proportional. Okay? So for right triangles, similar right triangles, those things are still going to be true. Okay? Moving on to the next slide. Okay? Now we're going to start talking about solving. Okay? So first, we're always going to use this structure. So we're given, just like I showed you in the last slide, we have a smallest triangle, medium triangle, and a large triangle. Okay? Then we have H, LL, and SL. Okay? Now, if you remember, the H, when we're talking about right triangles, especially means hypotenuse. Okay? Now, LL is going to be the large leg or long leg, however you remember. And then SL is going to be the small leg. Now, another thing to remember about the hypotenuse of a right triangle is that it is always across from the longest side of the triangle. Well, the hypotenuse is the longest side of the triangle. It's always across from the right angle. Okay? So you find the hypotenuse by looking across from the right angle. Okay. So, as a quick example, if you look at the medium triangle here, this is the right angle. Across from it, that would be the hypotenuse for the medium triangle. Okay. Now, this setup is actually pretty useful. It's going to be very useful in the future. It's asking what information do you know about each triangle. So if we look at the small triangle, okay, we don't know much about it. We know that the small leg is 1. We know that the hypotenuse has been labeled X. And again, we know that it's the hypotenuse because if this is the right angle, across from it is the hypotenuse. Okay? And we don't know anything about the large leg. So I'm going to put a hyphen. Okay? Now, if we look at the medium triangle, okay, the one that's in purple, if the small leg is 1 and the total on the bottom is 4, then that means the medium triangle, the bottom is 3. Okay? Now for the medium triangle, that's going to be the large leg. We don't know anything about the hypotenuse, so I'm going to put a dash. And we don't know anything about the small leg right now, so I'm going to put a dash. Now, if we look at the large triangle, overall, okay, we know that the hypotenuse of that, if we look at the where the right angle is, it's up here. So across from that is the hypotenuse. So we know that the hypotenuse of the large triangle is 4. Okay. We know that the small leg is x also, because it shares that side with the smaller triangle. And we don't know anything about the large leg, so I'm going to put a hyphen. Okay. Now, the cool thing about this strategy is that we can use it to solve for the missing leg. So the question we have here is, what ratio can we set up to solve for each variable? Okay. So what we want to do is whichever one we're trying to find, that's going to be our fraction. Now, when I say that, I mean that the chart actually gives you your fractions. So obviously we're going to be trying to solve for x because that's the only variable that we have. So where do we see x? Well, we see it here in this column. So that's our first ratio. And then we see it again in the third column. And that is our other ratio. Now, we have a ratio with a variable on both sides. Now, we can use something that we learned in the last unit to help us solve for this. Okay? We're actually going to use the geometric mean here. Okay? So again, for geometric mean, you want to first multiply the numbers together. And then second, take the square root. Okay. So now, if we look at the two numbers that we know, we're going to have the square root of 4 times 1, which is just the square root of 4, which is just 2. So just by that, we were able to figure out that the x's, if we go back up to the picture, are 2. So instead of x here, we can write in 2. And instead of x here, we can write in 2. So that's why we use this structure. We use this structure because it always gives you the fraction, and then you can end up solving for the missing part. Okay. Same thing over here. We got the small triangle. What do we know about it? Not much. We know that the small leg is 4. Okay. That's it. That's all we know for the small triangle. Okay. For the medium triangle, we know that the long leg or the large leg of the medium triangle is 12. Okay. We don't know anything else. Well, actually, let me go backwards. we do know something else. We know that the large leg for the small triangle is y, because it gives us a variable. So we know the small leg for the medium triangle is also y. Okay? But we don't know the hypotenuse. Now for the large triangle, we have the right angle here. So that means that if we look across, it gives us the hypotenuse. So it's not 4, it's not 12. We got to add them together, so we got 16. Okay. We don't know anything about the legs of the large triangle. Okay. So now again, we're solving for y. Okay? It gives us our fraction. So why we use this structure? We got y over 12. And then we got 4 over y. Nice and easy. Okay? Now, to solve, we just do geometric mean. So we got the square root, 12 times 4, square root of 48. It is not a whole number, so we can just leave it and say that the square root of 48 is equal to y. And we can go back and plug that in. So for here, we can say square root of 48. And for here, we can say square root of 48. We're doing this in class. I'm going to skip that for now. Okay. And I think that is actually all I got for you today. Okay, so until lesson 2. See you then.